Hello, this is Tommy. Welcome to Chatomics. Today I'm going to show you how to read all the files from a single folder into R and combine them into a single data frame. For beginners, actually reading all the files into R is usually a roadblock. And how you can even read multiple files into R automatically without repeating your commands. And to demonstrate this, I'm going to use a bulk RNA sequencing data. So the link is here. So this is a bulk RNA sequencing data for ovarian cancer. And it has actually 4 different samples, 2 control and 2 treatment. And let's download data just by directly click here. And it will be downloaded in your downloads folder, and you can double click it and it will actually unzip it. So if you double click into that folder, and there are 4 files there. Okay, let's actually now switch to the command line interface to look at those files. So I usually do ls-lnt head, so it will actually sort all the files by the time that you touch it. So you see those are the recent files that we just downloaded. So let's go into that folder. And we see those 4 files there. So those are zip file. You can, usually I use the zless to look at the zip file and specify the name of the file and look at the content. So essentially just 2 columns without header. So the first column is the gene name, gene ID, and second column is the counts. Okay, well, now let's go back to the RStudio and try to read all the files into R. Okay, so what people usually do is, okay, let's read in load libraries. So you can actually read one file in by using, for example, is a TSV file. You can use read underscore TSV, specify the full path for that file, one of them, and you can do that. And if you just use the head command to look at the first 6 rows, and it'll show you, okay, this is a data frame because we specify column name equals to false, so it will have x1, x2 as the default column name. Okay, so but you don't want to actually repeat this command 4 times for these 4 different files. So I'm going to show you how I do it. So you can first use the list.files command, and this is the folder name, and then specify full name equals to true. And if you look at this, so it just show you the full path of those 4 files. Okay. We also need to extract the sample name from those paths. So usually, I think this vehicle rep1, vehicle rep2, and those like treatment rep1 and treatment rep2. Those can be your unique sample IDs. Okay. So what we can do, we can first use the base name function. So it will remove all the previous path and only the file name. And now you can use this stream underscore replace function from stream R. And what I'm doing is that, okay, using regular expression to capture here, 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 and here. So the regular expression will be like dot plus, so dot like any characters plus like multiple characters, underscore ALDH here, and underscore, and then dot plus, and then you use the parentheses to capture the pattern that you want to actually keep. And then you actually replace this is the pattern, and this is your replace actually a pattern. So use //1 to denote actually this captured pattern. So let's do that. And if you look at samples, it will be the sample names, okay, unique sample names. Okay, in order to read in all those files, so you can use, so first you need to create a simple function to read in those counts, because all those different files, they have the same column name x and x1, x2. So you want to actually replace the x1 as the gene and x2 as the sample ID, okay, in order for you to actually combine all the counts together into a single data frame. Okay, so to do this, so you need just write the simple function here. So x is the path for that file, and sample is the sample name for that file. So you can read into that file by using read_tsv, and it's a data frame. And now you are changing the name of that data frame. So the first column will be the gene, and second column will be the sample name, right? Instead of x1 and x2, it will be gene and the sample name, and return the data frame. Okay. Once you have the small function, you can use this function called map2. So so you have to specify x and y here for map2 to work. So x is a vector of all the files, like this one, and the samples is this 4 actually unique sample names. And then you can specify the function read count you just specified here, and will actually this will be the x1, for example, and here will be the y1, and this will be the x2, and this will be the y2, and it will be actually automatically read by this map2 function. Okay, and actually it will return a list. So counts is a list of 4 here, and you can actually access each of the element by using double brackets, because it's a count, it's a list. So counts double bracket 1 give you the first data frame. So you see the column names are renamed as expected. And if you do counts number 2, then you see the column name is actually renamed correctly. Okay. Now you have a list of data frames, and now you want to actually combine all the counts into a single data frame. And because the gene column name is the same for all the data frame, you just need to do a inner join for all the data frames in this list of data frames. Okay, so what you need to do, okay, you use this reduce function in the per package and specify the list. So it's a list of data frame, and function you're going to use the inner join. So you will reduce what reduce function does is actually it actually apply this inner join function iteratively until it becomes a single data frame. Okay, let's do that. Okay, and let's look at the final table. So now we have a table that we can use actually for downstream analysis. For example, DSeq2 for differential gene expression analysis. So you have a single column for gene, and the rest are different samples, right? So this is pretty neat. So make sure you learn Google around to learn how to use the per function, the map function. Those are really handy in my daily analysis. Okay, so in this example, because we need to keep the same actually gene column, but if you have different columns, for example, you want to keep all of them, and you can use this bind columns function. And then let's look at the first 6 rows if you use that. So if you use bind columns, it will actually bind all the columns from all those 4 different data frames together. So because they have the same gene name column, so it will actually rename it gene ... 1, 3, 5, 7. But if you have actually a data frame with different column names, you can just use bind columns. Okay, that's it for today. I hope you enjoyed the video. Make sure you click subscribe if you like this, and see you next time. Happy learning.